My name is Friedmann Freund. My background is crystallography, material science, solid state, and I want to tell you today about some amazing properties that occur in the Earth's crust, of which the general audience is still largely unaware. There are something which we call positive holes everywhere in our environment, and I'll tell you more what these positive holes are. So let's skip the summary and go to this page here which says that there are strange experiences abound, that animals have been widely reported to act strangely before earthquakes, and that maybe many of us have experienced that the air feels heavy and weird just before thunderstorms. And the question is, can this tell us something about sleep? When we walk on the surface of the Earth, we don't realize that the ground is electrically charged. The reason is that strange defects lurk in the rocks deep below, and these defects affect our well-being and our sleep if and when they are activated. And the more they are activated, the more their effects, the stronger their effects are. This is a kind of busy slide, but it essentially tells you that, of course, the Earth's crust is full of water, and when the rocks are forming from magma that are saturated with water, minerals always contain hydroxyls, here shown in blue, and often hydroxyl pairs. And these hydroxyl pairs undergo a very strange chemical reaction, a classical redox reaction, where the two protons of these hydroxyl pairs are ripping off an electron from the oxygen and form a molecular hydrogen, which can escape, and the oxygens are left behind with a single negative charge, and they form what chemists call a peroxy link, a peroxy defect. Now the Earth's crust, the rocks in the Earth's crust, are full of these peroxy defects. They are very difficult, rather difficult to study, and not much is known about them. So positive holes then are the product of these peroxy, and you may not have heard ever about positive hole charge carriers, but they are part of our natural environment, and they affect the Earth's surface and the atmosphere. And they affect us during the waking hours and during sleep. And there is a diurnal rhythm in the activation of these positive hole charge carriers that is going with day and night rhythm. Now, what are positive holes? The Earth's crust is made out of rocks, and the rocks contain of minerals, mostly silicate minerals. And these silicates all have solidified in magmas in the presence of water. And as I showed in the last slide, some of these hydroxyls that are formed or left behind in the rocks form these peroxy defects. Now, this is the same slide as before. So when these peroxy defects are somehow activated, and this can happen either by stress or by heat, and we are mostly maybe interested here in the stress aspect, these bonds, this SiO-O-Si bond in the minerals or between minerals, when they act as a glue between mineral grains, and the mineral grains are shifted as part of the deformation of the rocks in the Earth's crust, this peroxy bond is extremely sensitive to changes in the angular bond. Here I show it as a linear structure, and as a linear structure it is stable as a peroxy, but as soon as this peroxy bond is bent, it falls apart. There's an electron transfer from a neighboring oxygen double minus, its regular oxidation state, and you form, the electron goes into the peroxy bond. Peroxy bond acquires an electron, and the oxygen double minus that has donated this electron becomes an O single minus. Now this O single minus is a very interesting and very active electronic defect in the lattice, sublattice of the minerals. It's an O minus, or the wave function associated with an O minus state. They are extremely mobile. They are electronic charge carriers, positively charged. They are essentially what semiconductor physicists would call a defect electron in the oxygen double minus sublattice of minerals in common rocks. And because of the presence of these positive whole charge carriers in the rocks in the Earth's crust and tectonic forces that act constantly, the Earth's surface is positively charged. And the more the Earth is being stressed, as it is before earthquakes, the more the positive charge accumulates at the Earth's surface. So these O minus are stress activated. And they are constantly continuously activated because the rocks in the Earth's crust are continuously stressed, and more so before earthquakes than at regular times. Though there is a variation in the concentration of these charge carriers, which are now here symbolized by H dot, which means H stands for the word hole in semiconductor physics. It's a defect electron, a missing electron in the oxygen sublattice. It's positive relative to its neighbors, and they are continuously activated. They have very interesting electronic properties that I cannot touch here now, but essentially they are responsible for our daily experience, having a ground at home where you can plug in. We can plug in our electrical appliances. There's one, the third contact is called ground. This goes into the Earth's ground, into some plate buried in the soil, in the rocks, and allowing us to dump electricity into the Earth, and therefore to operate our electronic equipment on the tabletop. But because these positive whole charge carriers are positive, the Earth's surface is positively charged. And also, because they are an O minus relative to O double minus, they are extremely reactive. Particularly, they are oxidizing. That means they would like to get back a second electron to reconvert to oxygen double minus. Then the H dot is consumed in the process and a partner is oxidized. And this activation of the positive whole charge carriers here, H dot, control our daily 24-hour rhythm. And they do more so than just day and night, light and dark cycle. So when rocks are stressed, many things happen simultaneously or consequentially. And in this rather busy slide here, some of these effects are listed. And I, of course, don't have time to address any of them except for the one, namely the activation of these positive whole charge carriers, which is the fundamental process shown here by the red on the left side bottom. When stresses are building up, positive whole charge carriers are being activated, and they then cause a number of secondary phenomena. One of the processes due to these positive whole charge carriers is they accumulate at the surface of the Earth, and they build up a positive surface charge that can reach values of millions of volts per centimeter, even though they are extending only over micrometer distances. A few volt in 1 micrometer corresponds to 1,000,000 volt in a centimeter. And therefore, the Earth becomes extremely reactive, and it can rip off electrons from the air molecules. And the air molecules that are donating, that are losing an electron to the ground, they then become positively charged. And this is bad, because positive air ions give us headaches, and it's essentially the sick building syndrome of which you might have heard. The sick building syndrome the term has been used to describe situations in which the occupants of a building experience acute health and comfort-related effects. And of course there are a number of causes, but they seem to be directly linked to the time spent in the building. And there's no single cause that has been identified, but one probably plausible cause for the sick building syndrome is the formation of positive air ions. And the symptoms caused by the sick building syndrome are the same as those that are experienced by people living in seismically active areas before major earthquakes or just before thunderstorms. In both cases, in the case of the earthquakes, the stresses underneath are activating these positive whole charge carriers, and they can travel. They travel actually at hundreds of meters per second, so they travel very, very fast, and they easily travel over distances on the order of 100 or 200 kilometers. So if in the neighborhood, in the radius of about 100, 200 kilometers, a seismic event is ready to occur and stresses are building up inside the Earth's crust, these electronic charge carriers become activated. The same happens because they are constantly activated in a low concentration level in the Earth's crust. When a thunderstorm drifts over the Earth, before the rain particularly, before the rain starts, the underbelly of thunderstorm clouds is negatively charged. This can be easily demonstrated by balloon experiments, and therefore these negative clouds are dragging along clouds of positive charge carriers in the Earth's crust, and that is the effect, physiological effect, is that just before thunderstorms, the air feels strange and heavy. So in total, as a conclusion, I want to point out that the rocks in the Earth's crust still hold many mysteries that are poorly understood. In particular, they contain strange electronic charge carriers, or I should be precise saying they contain peroxide defects which, upon seismic stresses, release positive whole charge carriers which can wax and wane in the diurnal circle. They cause the Earth's surface to become charged. In extreme cases, they cause the air to become positively charged, and many other processes that affect our physiology. So there is certainly a lot of room for further study of the effect of the processes in the Earth's crust on the physiology of us and in the animal kingdom. Thank you.